this lesson. We done with this shit. All right, guys. Let's get started. Hope everyone's doing okay. Today we're going to continue with the notes that we started last Tuesday. Okay, so I'm going to jump into notes number 36. The title of the notes is Adding and Subtracting Complex Numbers. Okay, so for today's notes, you're going to need 1, 2, 3, 4, 5, 6, 7, 8 boxes. Okay, that should be enough. All right. Okay, so today what we're going to look at is adding and subtracting complex numbers. So last time what we looked at was the imaginary number only, but the imaginary number, like we mentioned, is also part of something bigger called the complex numbers. Okay, so the complex numbers has a specific definition, and so that's where we're going to start. Okay, so a complex number is a number of the form a plus bi. Okay, so the complex number has these two parts, okay, where a and b are real numbers, meaning that the part where a and b are at, any number could be substituted in there. Okay, now the a is considered the real part, okay, and then the bi, this is the imaginary part. Okay, so when you have a number, for example, 3 plus 2i, okay, what we dealt with last time was specifically just the imaginary number, right? The number and the I, okay? So this would be considered the imaginary part to the complex numbers. And this part right here would be considered the real part, okay? So they're two separate, right? One is real, one is imaginary, but by combining them, by adding them or subtracting them, it becomes a complex number, okay? And that's what makes it complex, essentially, is that it takes one number from the real numbers, one number from the imaginary numbers, and then puts them together. Okay. All right. So the way that we add and subtract complex numbers is by parts. Okay, so we treat them as like terms. Okay, so you can add real numbers with real numbers, and you can add imaginary numbers with imaginary numbers only. Okay, and so that's what that first example is going to be about. Okay, so this is just a kind of brief introduction to the complex numbers. All right, so how do you add complex numbers? How is the sum of complex numbers going to look like? So the sum of complex numbers will essentially go like this. So let's say you start with one complex number. We'll call it a plus bi. Okay, that's your first complex number. And then you want to add it to another complex number. And that other complex number, we use different letters. So we'll call it c plus di. Okay. Here is how it works. 8 boxes. 8. All right, so here's how complex numbers work. It's really easy, okay? I want you to think of this as I can only add real numbers together and I can only add imaginary numbers together, okay? So, for example, A is a real number, C is a real number. How do we know they're real? It's because they don't have an I next to them, okay? If there is an I attached to the number, then that is an imaginary number, okay? So I'm allowed to add A plus C, okay? So I can kind of write this as A plus C. And now plus, I can add the imaginary numbers together. So I have bi and di, okay? I can add the b and the d together, okay? If I add the b and the d together, they still have an I attached to them, okay? It's only one I, all right? So I kind of want you to think of it as like, what if we were adding 3 plus 4x plus 5 plus 2x, right? You see, you can't combine the 3 and the 4x because 3 doesn't have x. It's the same idea with a complex number. You can't add it if it has an I, right? So that's why a and b can't be added together. You can, however, add the 3 and the 5, right? That would give you 8. You can add the 4x and the 2x because those are like terms. So that's 6x, right? So imaginary numbers or complex numbers work in the exact same way, okay? You can add the coefficients if they belong to both the real or if they both belong to the imaginary, okay? So it sounds complicated. It's a lot easier than what it seems, okay? So let's do an example. Let's start here with 4 minus 2i. That's the first imaginary number. Then we're going to add it to 3 minus 3i, okay, plus negative 4 plus 7i. Okay, so the first thing I want you to do is notice how we're adding everything together, right? So what you're going to want to do first is identify which one is real, which numbers are real, which numbers are imaginary, okay? So I have a real number 4, I have a real number 3, and I have a real number negative 4. Okay, I can add all 3 of those numbers together because they don't have an I next to them. So these are all of the like terms basically. So 4 plus 3 plus negative 4, right? Those combine, you got 4 plus 3 is 7. 7 minus 4, you go back to 3. Okay, so that's my real numbers. I can do the same thing with the imaginary numbers. Okay, all of the imaginary numbers, they have the I attached to it, okay? You want to keep the sign in front as well. So you see how it's 2i, but it's a negative 2i because of the negative in front. That's a 3i, but negative 3i because of the negative, and that's a positive 7i, okay? So now you do the same thing. You can combine these 3 terms together, okay? You're adding everything together, right? So you have negative 2 plus negative 3. That makes it negative 5. And then negative 5 plus 7, well, that's going to be positive 2. So now you get positive 2i, okay? You treat the I like a like term, okay? So you're not going to have like I to the third. No, you're adding everything together, okay? So the same way that if you added 4x plus 2x, that just gives you 6x. Same idea here, right? It's just combining the like terms between the negative 2, the negative 3, and the positive 7, okay? So that's it. That's your answer. Okay, so adding like terms is the same thing as adding complex numbers. That's it. Okay, nothing different. Any questions so far? Okay, if anything, again, doesn't make sense, just feel free to ask a question on the chat, okay? All right. Okay, let's move on. Let's do a subtraction of complex numbers, right? That was the sum because we were adding everything. Let's try subtraction. Okay, so example number 2. We have 3 minus 2i, and then we're subtracting 2 minus 3i, okay? All right, so in this case, because you're subtracting, what I would do first is I would distribute this negative, to the terms in the second parenthesis, okay? Because then I have everything listed out and I don't have to worry about like, do I add, do I subtract? You distribute the negative first, okay? So you think of this as being like a -1. So you distribute -1, that's gonna give you a -2. -1 times -3, that's a +3i, okay? What do you do with the terms in the other? You just drop them, okay? They just come down. So you get 3 minus 2i minus 2 plus 3i, okay? So now everything is there. Now you just combine your like terms, okay? So go ahead and highlight the real terms. That's going to be the +3 and the -2, okay? Those are real, right? Because they don't have any i's next to them, okay? Now, the imaginaries, they do have I, right? So I have a -2i and I have a +3i. Okay, so my yellows are my reals, my blues are my imaginaries. Those are the ones I'm allowed to combine together. So I have, whoops, 3 and -2. 3 minus 2 is just 1. Okay, -2 plus 3, that's a +1, right? +1, but remember, I'm combining like terms, so those i's come down together as well. Okay, so then that's it. That is my expression. Okay, any questions so far? Okay. All right, now let's take a look at something that's a little bit more complex. Okay, so with adding and subtracting, really, that's about as easy, about as about as complicated as it gets. Okay, now levels of complexity can be added to these types of problems when you don't have the I and you have to extract the I yourself. Okay, so for example, let's take a look at this problem here. The square root of -3 plus the square root of -27. Okay, they don't look like complex numbers, right? Because they don't have any reals, they don't see any imaginaries. Okay, so you have to do the conversions first. Okay, so the first thing is when you have the square root of a negative is you extract the I, right? We did something like this last week where we had to convert these into imaginary numbers. Okay, so how do you do that? Well, remember that the square root of -3, I'm gonna do a little scratch work out here, represents the same thing as the square root of 3 times the square root of -1. Okay, what does that mean? That means that this part right here, the square root of -1, because you're able to extract it, that's where your I comes from. And then you just bring down square root of 3. So when you have a negative inside of the square root, you can take the negative out, but if you take the negative out, you have to include I now. So this becomes square root of 3I. Okay, remember that I goes at the end of the expression, not in the front. Okay, now the same thing happens with 27, right? So we have plus the square root of, I can change this to +27, but if I change it to +27, I need to bring the I to the outside. Okay, all right. Now this is where it gets a little tricky. Okay, I have the square root of 3 and the square root of 27. You cannot add square root of 3 plus square root of 27 to get square root of 30. That is a big no. Okay, do not do that. Do not do that. Okay, here's what you need to do instead. You take the square root of 27. You have to simplify that because 27 is not in the most reduced form. Okay, so what you do first is, okay, I need a factor tree. So start with 27 and you look for factors of 27. So I could say probably 9 times 3. What you're trying to do is reduce 27 to the simplest form possible. Okay, so 27 is no longer active because you factored it. Now keep factoring. Well, 9 is 3 times 3. So 9 is no longer active anymore. All right. So now you look for a pair, right? You look for a pair of numbers. Well, I have a pair of 3's. So there's my pair. Okay. But this 3 is left over. So any leftovers, remember that the leftovers go back inside the square root. So I have my square root. This 3 right here from the box is going to go back inside. The pair of 3's, right, the ones we were able to group, If you get a pair of 3's, then you get to write 1, 3 on the outside. Okay, so that becomes 3 root 3. Okay, now so that means that the square root of 27 actually represents 3 root 3 I. Okay, I get to bring down the other root 3 I. Okay, now why was it important to do that? Because now we can simplify what we have. Okay, again, I want to go back to this idea of combining like terms. You can only add like terms, you can only add coefficients if they have the same variables, right? They have everything in common. Okay, well, I want you to think about this. There's no number in front of this square root of 3, right? There's no number there. But I can include a number if I wanted to. I can always put a 1 in the front here, okay? Because basically it's like saying 1 times the root 3. 1 times root 3 doesn't change, right? It's still root 3. Now, what that does allow me to do is that now I have a coefficient. So 1 is a coefficient. 3 is a coefficient, okay? When am I allowed to add coefficients? I can only add coefficients if they have the same like terms. That means they have to have the same tail, meaning they both, in this case, if my coefficient is 1, I need to check, do both of the terms have a square root of 3? Well, yes, they do. Then, do they both have the letter I? Yep. Okay, they both have that, right? So I want you to think about this as, what if it was like 1xy plus 3xy? Right? Because they both have x and they both have y, couldn't you add these together to make this 4xy? It's the same idea that we have here, right? They both have root 3 and they both have I, okay? So what you're allowed to do is you're allowed to add the 1 plus the 3 together to get 4. 4 of what, right? 4 of what? Well, you got to think of square root of 3, that's kind of like your x. Then your y, think of that as like your I, right? So then, what is it that you would combine? Well, you would bring them together as 4 root 3 I. Okay, so the only thing that changed was that you were able to add these coefficients right here, the 1 and the 3. You got to think of 3i, square root of 3i, as the variables, right? You don't technically add the variables together, right? You just kind of bring them down like we did here, xy, because they both have the same x and they both have x and they both have y. You can add the 1 and the 3. That's what's happening here, okay? So I hope that makes sense, because that's the trickiest part about adding and subtracting like terms. Okay, it's once you get the square root and you get the I involved, it becomes a little tricky. Okay, you're allowed to add coefficients, but you are never allowed to add the inside of a square root with the inside of a square root. You can multiply the inside of a square root times the inside of a square root, but you cannot add the inside of a square root with the other. Okay, adding doesn't work. Multiplying, yes. Okay. All right, so again, if questions come up, let me know. We're going to do another one just like this, very similar, okay? All right, so here, example number, this is 4, I believe. Yeah. So for example 4, let's say we start with 3 root negative 2 minus root of negative 50. Okay, so let's say now we want to simplify. Let's start with the first one, right? The first term. Here you have the square root of negative 2. Remember that the first thing you do is extract I, right? So the 3 on the outside will stay. This will now become a square root of, instead of negative 2, becomes a positive 2. But what else do you need? Because you removed the negative, now you need the I on the outside. Okay, so you've converted it to imaginary. Now you have an I to work with. Okay, minus, here we get square root of, we can change this to square root of 50, but because we removed the negative from the inside, right, this negative, now we have to convert it and put the I on the outside. All right, so at the moment we can't combine any terms because the only thing they have in common is the I. Having I in common is not enough. They both need to have like the same square root. Okay, so since one of them is square root of 2 and the other one is square root of 50, there's no way to combine it yet. So what do? We take 50 and you take that into a factor tree and you try to break it down as much as possible. Okay. Well, 50, that could be 10 times 5, right? Well, 50 is no longer active. Now you factor 10. Well, that's 2 times 5. 10 is no longer active. Okay, do you have a pair of numbers left over? Yes, you do, right? You have 5 times 5 right here. Okay, so even though they're not on the same branch, you can collect them. So I have a pair of 5s, and then this 2 is left over. So what do you get to do now? Well, that means that when you do the square root of 50, inside of the square root is the leftover. It's the loner, right? So the 2 goes inside. The pair of 5s, what happens to that? Well, the 5 is what gets to come to the outside, okay? But you only use 1 5, not 2, just 1, okay? So it's 5 root 2. So that means I get to rewrite the square root of 50 as the 5 root 2, then drop the I, okay? That's a negative, right? And then now I get to bring down the 3 root 2 I, okay? All right. So now let's see if we have enough like terms to be able to combine coefficients. Okay, so remember the whole number in the front, that's the coefficient. That's my coefficient. Okay. Do they both have root 2? Yes. Right, they both have root 2. Do they both have I? Yes. Right, so again, this is kind of like saying 3xy minus 5xy. Think of the root 2 as the x that they both have, and think of I as the y that they both have, right? Because they both have the same variable, you get to combine the coefficients, okay? So you get to combine 5 with negative 3. Well, 5 minus 3 is going to be negative 2, okay? The rest, right? This is grouped together, okay? Because they have the same, then you just bring this down. So it's going to be negative 2 root 2 I, okay? And that's it. So the important part here is you simplify as much as possible. So if you have a big number, square root of 50, first you break it down as low as possible. Because once you break it down, what you'll find is in the most simplified form, they have things in common, right? If we wouldn't have broken down square root of 50, there's no way we would have been able to combine it because they're not the same square root. But once you simplify it, you were able to pull a 5 out. So now you have a coefficient. And then what was left over? You had the square root of 2. Well, then that matched the other square root that you had on the other side. Obviously, they both have I, so they have that in common. So now that they both have square root of 2i, then you can combine these coefficients, which is the 3 and the negative 5. Okay, and that's how you get negative 2. Okay. Any questions there so far? Okay. All right, let's move on. Okay, so example 5. Okay, so with example 5, it's going to get a little bit more complex. Okay, so just stay with me. So we have square root of negative 3c squared. Okay, so the c squared is inside right now. Plus the square root of negative 27c squared minus the square root of 45c squared inside this root. All right. Okay, so let's start with the first one. We break it down into 2 parts, okay? Because we're dealing with both a number and a variable on the inside, okay? Remember that if you have a product inside, right, like negative 3 times c squared, you can break it up into 2 smaller square roots. You can break it up into the square root of negative 3 times the square root of c squared. Okay, now why is it important to do that? Because then it makes the problem a little bit simpler for you. Okay, I want you to then think about, well, what's the square root of negative 3? How can I simplify that? Well, remember that if you have the option, you extract the I. Okay, so then this becomes the square root of 3i. Okay, and then what happens with the square root of c squared? Right, a square root and a square, aren't they inverses of each other? Right, so the square root and the square cancel, so then you just get to drop the c. Okay, now this looks a little awkward, okay, because I have I and then I have c. I'm going to rearrange it, okay? If I have a number or a letter that's not I always stays at the end. But if I have a letter like C, I don't want it to be at the end. I'm going to bring it to the front. Okay, I'm going to bring it to the front, okay, to separate, right? I want to keep the I separate from anything else that's not imaginary. So C comes in the front, then square root of 3, and then my I at the end, okay? That looks a little bit better now. So I'm going to try to keep this convention. Any variables that come out, any variable that's not I, we bring them to the front. Then the square root, and then the I. Okay, so typically the square root is the division between your I and whatever else comes out of the problem. Okay, so we're done there. Now we do the same thing with the square root of negative 27 c squared. Okay, so we split. This can be the square root of negative 27 times the square root of c squared, right? Because there's a product here between negative 27 and c squared. Okay, the easy part is identifying that the square root of c squared is just c. Okay, we can also simplify the square root of 27 to be, or the square root of negative 27 to be square root of 27 I, right? Because we're going from a negative 27 to a positive 27, so that negative has to go somewhere. It becomes the I. All right, now square root of 27, we already did that earlier. Where was it? Right here, right? We did 27, we broke it down into a factor tree. This is what we got, right? So let's not redo the same work. Let's just copy what we have. We know that the square root of 27, right? We took square root of 27, we did the work, we got 3 root 3. Okay, so that's what I'm going to turn this into. So square root of 27 becomes 3 root 3 I and then C. Okay, so like I said, C looks awkward at the end. The last term should always be I. So I'm going to bring the C in between the 3 and the root 3. Okay, I'm going to try to keep it in the same position as what I had in the first expression. Okay, so this is still plus, this is still plus. So I'm going to rewrite this as 3c root 3 I. Okay, see, all I did was I moved the c right in between 3 and root 3. That's all. Okay, I'm allowed to do that because this is a product, so you can rearrange the product and the answer is still the same. Okay, all right, last one, we have minus root of 45 times root of c squared, right? We split the product into 2 smaller parts. Okay, easy one here is the square root of c squared is c, because the square and the square root cancel. Okay, all right, now 45, big number, most likely can be broken down. Okay, so we need to go through the breakdown process. So take 45, factor tree it. Okay, what times what gives you 45? Probably 9 times 5. Okay, so 45 is no longer active. Okay, then 9, you can factor that even further. That becomes 3 times 3. Okay, so then what do we do with the pair? We circle the pair and then we box the loner. Okay, so what does that mean? That means that the pair gets to come outside of the square root. So we have a 3, and then the box that goes inside the square root. Okay, so what we've done now is we've taken square root of 45 and now we can rewrite it as 3 root 5, and that's the simplest form possible. Okay, so now minus 3 root 5 c. Okay, notice the thing that's different about this one is that 45 was never negative, right? So square root of 45 is not going to give us imaginary. That's why an I never came out, right? 45 was positive from the very beginning. Okay, the minus is on the outside. That doesn't affect anything because the negative has to be inside for us to be able to turn it into I. Okay, so now see where my c is at? It's awkward, right? So I'm going to bring it in between. I'm going to write it 3c root 5. Okay, so that becomes 3c root 5. Okay, so now let me bring everything down and then let's see if we have anything that we can combine together with like terms. Okay, first thing you look for, do they both or do they all have I, right? Check to see which ones have I, because if they have I, that means that they're imaginary. You cannot mix the imaginaries with the real. Okay, so what do you see? You see the first 2 terms have I. Those are imaginary terms. The last one does not have I. That means that this entire thing is real. That means you cannot combine this, including that negative, because it's part of it, so negative 3. All of this, none of it can be combined with term 1 or term 2 because it's real. Okay, this is the real part of the expression. Okay, now the other two, those are imaginary. So you can combine imaginaries if they have everything else in common. Okay, so I want you to take a look here. 3 would be my coefficient. Okay, now do I have a coefficient for the first term? I have c root 3, but I don't have a number. So what number can I put in the front? I can put a 1, right? I can put a 1 because multiplying by 1 doesn't change it. So then now at least that gives me a coefficient to work with. So 1. Okay. So now I see that my coefficient is 1 and 3. They both have I. Let me see if everything else is the same, which means if the first one has a C, well, then the second term better have C. And they do, right? So at least they match there. They have the same variable. Do they both have the same square root? Yes, right? They both have square root of 3. Okay? And obviously they both have I, right? So do you see how they have exactly the same thing? They all have C, they both have square root 3, they both have I. Which means what can you do with those coefficients now? You can take 1 and you can add it with the 3 and you get 4. For what? For C root 3 I. Okay? Then you can bring down the real number, right? That real number was never going to combine with the other ones because the reals and the imaginaries don't mix. They have to stay separate. Okay? So now we have minus 3c root 5. Okay? So now what's awkward about this? What's wrong with it? Well, a complex number, you have a real and you have an imaginary. Which one goes first though? The real or the imaginary? Okay, go back to the standard form, right? Right here. A plus bi, remember A is the real, B is the imaginary. So it's supposed to go something like this, where the real is in the front and the imaginary number is in the back. So we got to rearrange what we got in example 5. We just have to rearrange it. Okay, so since this part is the real, including that negative, that has to be written first. So negative 3 c root 5. The imaginary part, which is in green, that we write in the back. Now that 4 is a positive 4. So then that's going to be plus 4 c root 3. And the fact that there's an I attached to it is what makes it imaginary. Okay, so then that is the solution to this expression. Okay, how we doing so far? We okay? Okay, please let me know if you have any questions so far. All right. And now let's do one last one. Okay, one last one just to kind of get comfortable with all of these moving parts. Okay, so for example, number 6. Okay, something similar. Okay, something similar. So we got the square root of negative 25, a to the third. Okay, the a to the third is inside the root. Minus the root of negative 225, a to the third. Plus 20a root negative a. Okay. So remember, the first thing we do is try to break this up into those smaller parts. Okay, so in this case, what we want to do is take that root negative 25 times the root of a to the third. Okay, well, let's start with the root 25. Okay, well, that 25, remember, we want to extract the I first, so we can turn that into root 25. It's a positive 25, but because it went from negative to positive, there has to be an I that gets extracted, right? So square root of 25 times I. Okay, now what's nice is you know what the square root of 25 is, right? The square root of 25, that's just 5. So this is 5I. Okay, now how do we deal with this part, the square root of a to the third? Well, same way you would with a factor tree, okay? So let's say you had a to the third. Well, doesn't that represent a times a times a? Okay, remember that you're looking for a pair, so it's a group of 2. Well, I have a group of 2 here, and then I have one a that's left over, right? Okay, well, what does that mean? That means that then I have a square root. This a will go back inside, and then this pair of a's, they escape, right? So together, it's just, they form one a on the outside. Okay, so what do I have now? I have a root a. Okay, that's what a to the third, or the root of a to the third becomes, a root a. Okay, I bring that down. Okay, now what's awkward about it? Where should the I be? Okay, right now the I is like in between the coefficient and then the variable and then the square root. I should always be at the end, right? So let's rewrite this. We're gonna have 5, then any variable, then the square root, and then I at the very end, right, on the outside. Okay, so we've simplified that first part. Okay, let's move on to the next part. Okay, we have minus. Again, this is gonna split. We can keep here the square root of negative 225, and then times the square root of a to the third. Okay, well, lucky for us, right, we can take care of that number. That becomes a minus square roots of, well, we can turn that number positive now, 225, and then we pull the I out. Okay. All right, now what's nice about the root of a to the third is that we already did that work. Right, so there's no need to do it again. We know what it becomes. It becomes a root a. So let's just convert it to a root a. All right. Now, if you were to try to find the square root of 225, that's actually a really nice number. You can take the square root of it. So the square root of 225 actually becomes 15. Okay, 15. So you bring down the minus, you have 15. You can bring down I, and then you have your a root a. Okay, and again, it looks a little awkward because I is not where it should be. I should be at the end. So all we have to do is rewrite it. So we can subtract 15, then the variable a, then the square root a, and then I at the very end. All right, now finally, we'll get to the last one. We have plus 20a, okay? Now, how can we turn this square root of negative a into an extraction? How do we get the I out of it? Well, you can just keep it as root a, right? The a is now positive, but because you extracted out the negative, now that you have the I at the end. Okay, now what's nice is that there's nothing else to do, right? It's just 20a root a I. You can't take the square root of a, so now go ahead and just drop that, bring it all the way down. Plus 20a root a I. Okay, so now let's see. Identify your coefficients first. Your coefficients are your whole numbers, okay? Your whole numbers and the very front, okay? So that's why it's so important to write it out correctly and to put things in a correct order, because the coefficients, your whole numbers, should always be out front. So I have a coefficient of 5, coefficient of negative 15, right? See how I'm including the negative, and then a coefficient of 20, okay? All right, so now coefficients can be combined only if what? They have to have everything be the same, right? First of all, do they all have imaginaries, right? Because if they don't have all imaginaries, then you can't combine them with anything. But let's see, this one has imaginary, this one has imaginary, this one has imaginary. Okay, because they all have imaginary, we can combine everything, right? They're all imaginary numbers, so we can combine them together. Only if they have the same variables, right? They have the same terms. Well, let's check. Do they all have a? Yes. Okay, do they all have square root of a? Yes. And do they all have I? Well, we already knew that, right? So they all have this particular piece. They all have a root a I, a root AI, a root AI, which means that you can add your coefficients together. So you can take the 5, the negative 15, and the 20, you can add them together. Okay, well, 5 minus 15 is 10. I'm sorry, negative 10, and negative 10 plus 20 is positive 10. Okay, so you end up with 10. 10 what? Well, bring down whatever it was that you bubbled. Well, I bubbled a root a I. And there is my final answer right there. Okay? And that's it. Okay, so that's pretty much it for me. Those are the only notes I'm gonna give. Are there any questions about any of these problems? Okay, so quick reminders. Thursday. Okay, we have a Zoom at 12 p.m. Okay, I'm gonna do homework problems at 12. Okay, and then also on Thursday you're gonna have a quiz on these first 2 set of notes. Okay, because I don't want to go into spring break and then have to come back and then you spent a whole week without doing any math. So I don't want you guys to forget anything. So there will be a quiz on Thursday. Your quiz will be on notes 35 and notes 36. So this lesson and the lesson from last Tuesday. Okay, so I'm gonna zoom from about 12 to about 12:30 or so. In fact, maybe I'll open up my Zoom a little bit earlier. So typically I'm done. So I'll do like about 11:45. Okay, open it up early so that we can answer any questions right before the quiz. So from 11:45 to about 12:30 p.m. will be Zoom, and then your quiz will open at 12:30 until the end of what class usually is till about 1:45. Okay, so it'll open at 12:30 and it closes automatically, right? So it'll kick you out as soon as 1:45 hits. However, when you go in, you're not gonna have an hour. You're not gonna have an hour and 15 minutes to do a quiz. The quiz is short, right? It's like what we do in class, so you have like about 30 minutes. So I'm gonna give you 40 minutes to do your quiz, which should be plenty of time. Okay, it's gonna be just like how we did the test. You submit your answers on Edulastic. You submit a picture with all your work on Schoology. Okay, so I'll send out instructions on that. Okay, but it opens at 12:30, so that means you can start exactly at 12:30. Once you start, you only get 40 minutes. Okay, so after, you don't think that you can start at 12:30 and then you have until 1:45 to finish. That's not how it goes. You can start whenever in between that time, but you only have 40 minutes. Okay, so let's say you jump on at 1:30. Well, you're only giving yourself 15 minutes because it's gonna close at 1:45. Okay, so make sure that you start early enough, right? So the latest that you should start is like 1 o'clock. Okay, that way you have your full 40 minutes to do your quiz. Okay. Any questions on that? I know there's only 3 of you watching, so share with your friends from class. Okay, there's not a lot of people who are tuning in and I'm a little bit concerned, so please tell your friends to watch the videos and let them know that you have a quiz coming up. Okay, all right. So with that being said, the other thing that I wanted to mention is that I will give you the Unit 5 retake opportunity. So I know that we took Unit 5 like on Edulastic about 2 weeks ago. So I'm actually I just wrote the retake. I'm going to give a retake opportunity and I'm going to send out those details in about 10 minutes. Okay, so the retake opportunity for the Unit 5 test is going to happen during spring break. The reason for that decision is to give you a little bit of a break from your other classes so that you're not overwhelmed with work and trying to study for a retake at the same time. Okay, so I'm going to open that up for 2 days during spring break. There's going to be a big window of time so that you have flexibility, but once you start the test, you only get 2 hours to finish it. Okay, so that's how the structure of the unit retake will be. You're gonna have to let me know what day you want to take it, so I'll post the days. Because once I know what day, then I'm also gonna send you a video showing you how to correctly do each one of the problems, so that's how you're gonna study. So you need to watch the video, you need to take those notes. You can use those notes to help you on your retake. Okay, so obviously they're different problems, but they're very similar. Okay, all right, so that's pretty much it. So please, please, please do the homework, try the homework. Okay, so I will upload homework number 2. Okay, we'll go over those homework problems on the Zoom session on Thursday. Okay, for homework 2. So you can ask questions right before you take your quiz. Okay, so it should be fresh. It'll be just like we do in class. All right. All right. Well, then thank you for tuning in. I appreciate the few of you who actually keep me company while I do these live streams. Okay. All right, guys. Have a good day. Let me know if there's any questions. Always feel free to message me. All right. Take care.